So we've had a question kind of like this before. And my question to you that I want you to pause and think about is which, whoops, which are the same? Dun, dun, dun. I'm going to put three fractions up here. Which of these are the same? Okay. Just going to write. Okay, pause the video, think about that. Which are the same? I'm going to keep going. So, this is such a crucial question and a crucial piece of understanding for the notation aspect of algebra. Understanding how the variables and the fractions all work together with the way we write things, right? Because if you don't understand the notation, then what you do next doesn't matter. So, if we think about what we've already learned about multiplying fractions, what I'm going to do is I'm going to start with this one. I'm going to examine this one. So what this means right here is we have the number 2/3, and we're going to multiply it by x. So I would write it like that. Okay? But we also know that we can write a whole number over 1. So 2/3 could be written, or 2/3 x could be written as 2/3 times x over 1. Well, then we know when we multiply fractions, we multiply straight across. So we would multiply this times this and this times this, which equals 2x on top over 3. So what does that tell us? It tells us that 2/3 x like this, where the x is off to the side, and 2x over 3 have the same value. These are equivalent. These are the same exact statement. This one in the middle is different, right? This one's different from the other two. This says we're going to take 2 and we're going to divide it by whatever 3 times x would be. That's much different than saying 2 times whatever x is divided by 3. Those are very different. So if your variable's off to the side, you can move it up to the top. If it's up top, you can move it off to the side. They mean the same thing, which is going to be crucial for this next thing, which is solving equations that have fraction coefficients. Because that's what this is. Remember what a coefficient is? It's the number in front of the variable. Solve. Here's an equation. 1/3 x is equal to 5. So, solve. In your head, say it out loud. What does it mean to solve an equation? Find the value of the variable that makes the equation true. Okay. So, our goal is always to isolate the variable, to get that x by itself alone. So, we look at it. We say, well, what's the problem? What's the thing that needs to go away from the x if I want it to be by itself on its side of the equal sign? Here's the equal sign, right? I've got an x, but I've also got this times 1/3 thing. I need this thing to go away, right? I need this thing to go away. I need it to be gone. So how could we get rid of it? Well, think about what we want to turn that number into. Don't we want that to be 1x? Don't we want it to just say 1 times x, which is x? How could we change that into 1? Well, think about what we've been talking about with fractions where the top number and the bottom number are the same. If we multiply this thing right here by 3 or 3 over 1, what's going to happen here is 3 times 1 is 3. 1 times 3 is 3. They cancel out. It just becomes 1. What we're doing is we're multiplying both sides of the equation by the reciprocal of the coefficient. Multiply by the reciprocal. That is, when you take the fraction and you invert it, change the position of the numerators and denominators, multiply by the reciprocal of the coefficient. That means the number that's attached in front of the x. When we do this, I'm going to just add a little step here. 3 times 1 is 3. 1 times 3 is 3. And now we have 3/3 x equal 15. And notice how I just wrote times 3 on the right side rather than 3 over 1. It's the same thing. It was just more convenient for me to write it like that because I'm multiplying two whole numbers. And then 3 and 3 cancel to make 1. And then the multiplicative identity says that should just be x equals 15. So there we go. We've now solved an equation that has a fraction coefficient. Let's do a couple more. So next we have 2/3 is equal to 1/5 x. Actually, I'm going to put the x up there. 1x over 5. All right. So remember a minute ago we talked about where that x has to be placed? This notation right here means the same thing as 2/3 equals 1/5 x, like that. Okay? Those mean the same thing. The coefficient of x here is not 1. It's 1/5. Coefficient is 1/5. And don't be confused because the x on the right side, yeah, there's a fraction on the left, but what we care about is the coefficient, which means the number in front of the variable, 1x. So how do we get this variable here all by itself? We need to get rid of 1/5, right? Which means we multiply by its reciprocal. Multiply by 5 over 1. Multiply this side by 5 over 1. Here I'm going to write 5 over 1 because I'm multiplying it by a fraction. Multiply. 5 times 2 is 10. 1 times 3 is 3 equals. Notice this stuff right here, the 5s and the 1s, when we multiply, we just end up with 5/5 x, which can cancel out. And we're left with 10/3 equals x. It doesn't matter that the x is on the right side. It still works the same way. Okay, next one. Negative, I did it to you. Negative 3y is equal to, or over 4, is equal to 7/5. Pause it, try it. My first question is, what is the coefficient? Find the variable. It's y. It's got a negative 3 in front of it, but it's really negative 3/4. So the coefficient is negative 3/4. I need the negative 3 and the 4. I need that whole thing to disappear. So we multiply by its reciprocal. We multiply by negative 4/3. Doesn't matter where the negative is. Remember, the negative can be anywhere in the fraction. As long as we're multiplying a negative by a negative, it's going to cancel out that negative. So we multiply both sides of the equation. Right, here's my equal sign. Both sides by negative 4/3. I'll show this a little bit differently. Over here, the 3 and the 3 cancel, the 4 and the 4 cancel, and the negatives cancel. And we're left with just a y equals. Over here, nothing cancels, so I just multiply straight across. 7 times negative 4 is negative 28, and 5 times 3 is 15. So we're getting sometimes answers that are fractions, and that's fine. One more. Try this one yourself. 10 equals 5/6 m. Pause it, give it a shot. So, we have a whole number, right? We've got a whole number on one side. Whole number on one side equals to 5/6 m. We pause, we scan it, we sort of examine the whole problem. Here's my equal sign. My variable's over here. I've got to get rid of the 5/6. It's a fraction, so we multiply by its reciprocal, 6/5. Multiply this by 6/5. Now, one thing you might do, it's totally a legal move, we have already talked about it, is on this side where we're doing the multiplication, we have a fraction times a whole number. So you might do what? Put it over 1. That might help you make sure you're multiplying the correct things together. So let's do that. 6/5 times 10. There are two ways you could do it. You can multiply 6 times 10 and 5 times 1 and get 60 over 5. I'm going to do a little cancellation. I'm going to do a little shortcut cancellation. I'm going to think of the number 10 as 2 times 5. Cancel this 5 with the 5 in here, which leaves me with just a 2. So I'm really dividing both of these things by 5, right? When you are multiplying with fractions, you can cancel common factors. And I canceled a 5 from here and here, which leaves me with a 2. Earlier, we were doing that, writing out prime factorizations, which you can still do. 6 times 2 is 12. 1 times 1 is 1. We'll take care of that in a minute. 5/6 times 6/5. These all cancel, leaving us with just that variable, right? These all turn into 1. That's what we want. And then 12 over 1 will simplify to be 12. So again, you could cancel, or you can do 6 times 10, which is 60, divided by 5, which is 12. Either way is going to work for you. And that is multiplying or solving equations when we have fraction coefficients.